So let's do number 5 now. So it says, what is the magnitude of the average acceleration of a skier who's starting from rest reaches a speed of 8 meters per second when going down a slope for 5 seconds? All right, so let's go ahead and list our unknown. I'm just going to copy and paste this one here and see if we can make some changes. So this is part A, and then we're going to see what changes we need to make. Starting from rest, so V0 is 0, reaches a speed of 8 meters per second. That's going to be the final velocity is 8. And then for 5 seconds, so T is 5. And then we're solving for A here, average acceleration. All right, so let's go ahead and uncomment that line. And let's see, do we change this equation here at all? So we have V0, V, T, and A. So I have V0. So I need to change this equation to something else. And then let's uncomment this one. So we need to find one with V0, V, A, and T. So that would be V0, V, A, and T, this equation here. So copy and paste what's on the right side of it. So we're going to come down and then paste that into our equation command. Paste it, and then on the right side we have V only, not V squared. Change that, and we're solving for A, and we take the first equation, or first solution of those, and then let's do our substitutions. So V is 8, and then T is 2 here for 5 seconds, so it should be 5. T should be 5. Yes, T is 5, so, and here I need to change that to 5. All right. So the acceleration is going to be, it's already in the print command here, so I don't need to change that. So let's go ahead and run it and see what that acceleration of the skier is in 5 seconds. So A is 1.6. Again, I should change the centimeters to meters. So let's see. Let's make a conclusion as soon as we run the code. So starting from rest with a speed of 8 meters per second, the acceleration for 5 seconds is going to be 1.6 meters per second squared of a skier. All right, so that is part A. Go ahead and comment that. So part B, let's go ahead and copy and paste this, see if we can use as many as we can of those. So this is part B here. All right, part B. So it says, how far does a skier travel in this time? So we know that V0 is 0, V is 8. We don't know what T is. So we are given, or we actually found, all right, so yeah, we have T, and then now we're solving for X here. So it says, how far does the skier travel? So that is a displacement. So X is the unknown variable in this case. All right, so X is symbol that. But notice here, we can just copy and paste the equation that we need from above, because that has V0, V, X, and T. And we don't need to solve for any other equations. V0, V, X, and T. This equation here, so copy that equation and then come down here and paste that in here. So then solution equals X here, X dot subs. Yes, just like that. And then we have X is, this is going to be meters. Yep, like so. Let's go ahead and run it. Oops, I need to uncomment this line. So let's go ahead and run the code and see what we get. So displacement is 20 meters of the skier for 5 seconds, going with a speed of 8 meters per second for 5 seconds, starting from rest. It's 20 meters. All right, so that's how we do that problem. So let's do the last problem here, and that would be it for today. Hopefully you'd learn something, and we might come back to doing more kinematics on a different day. But all right, so it says a jetliner traveling northward is landing with a speed of 69 meters per second. Once the jet touches down, it has 750 meters of runway in which to reduce its speed to 6.1 meters per second. Compute the average acceleration, magnitude, and direction of the plane during the landing. All right, so let's start listing our knowns and unknowns in this problem. So in this case, V naught is the speed here. That's going to be V naught, speed of 69 meters per second. That's going to be the landing speed. That's sort of the rest speed of the plane before it makes a final landing, basically. Or, yeah, to reduce it, reducing to the speed of 6.1, that's the final speed. So this is going to be 69, and then V final here is 6.1. Let's see. So this 750 meters, that is going to be X. So X here is 750, and then we need to solve for A. Acceleration is the unknown variable that we need to solve for. So let's go ahead and uncomment this line. So we need to now borrow this line of code from number 5 and paste here, and then change things. All right, so we need an equation that has V naught, V, X, and A, and that's not what I have here. So let's go back up and see which one. V naught, V, A, and X, that would be this fourth equation down here. So copy that, and we're gonna paste that into our equation command. So Control V, and then this is V squared, and we're solving for A here. So let's go ahead and comment that, and then so V naught is 69, V is 6.1, and then X here is, let's see, 750, like that. And then we are printing the acceleration in meters per second squared. That's fine. Let's go ahead and run the code. We should get a negative number. Yes, so A is negative 3.1492. So basically negative pi meters per second squared. It's sort of close to pi, negative pi. But that's ironic. I mean, that's just a coincidence. It's not supposed to be pi. The acceleration of a plane with a speed of 69 meters per second and a final speed of let's see, was it 6.1 and 750 meters of runway. We don't get that it's negative pi, but coincidentally, A is negative 3.1492 meters per second squared. All right. So I'm gonna comment this, and that's how we solve kinematic applications or word problems involving kinematic equations. That's a concept of algebra-based physics. And we did that using Python. Thanks for watching.